Hello everyone. Today we will try to answer this question. We are required to calculate the equivalent resistance that goes through the circuit, or RAB. Now, the first step is for you to identify all the nodes in this circuit. So, recalling the definition of a node separates between two different elements. For example, this one over here. As you can see, this node over here separates the 1 ohm resistor from the 5 ohm resistor, so we call that a node. Now, let's try to identify all the other nodes using the same definition. There is one node over here because this one separates the 10 ohm from the 3 ohm. It also separates 10 ohm from the 6 ohm and also from the 1 ohm, so all of them share one single node. Now we know that there is another node over here because this node separates this one from this one. It also separates the 1 ohm from 4 ohms, and it also separates this 1 ohm resistor from this 12 ohm. Now what about the bottom one? Well, as you can see, there is one node over here because this one separates 5 ohm resistor from 4 ohm, and there is one over here because this one separates 3 ohm from 12 ohm. However, if you look closely, there is no element in between these two nodes as such for this one. So that means this one whole wire down here is one single long node. I hope that part is clear for you. Now, after we have identified all the nodes in the circuit, the next step is for you to simplify and redraw the circuit until to the point that you can calculate all the circuits using just series or parallel equations. So let's start with the obvious. As you can see here, this 1 ohm resistor connects to this 5 ohm resistor in series. That means we can just combine them by summing up their resistance. Now, if we redraw that, this is what we will get. This configuration right here. The only difference between this circuit and the previous one is that I have combined the two resistors, making it 6 ohm. Now, how about all the others? How about all these convoluted circuits you see over here? How do we solve this? That brings us to the next step, which is to assume current directions so that we can redraw the circuit again. So let's start with this 10 ohm resistor. I will assume that the current goes through here, and then it goes through the 3 ohm resistor, and then it comes back to the terminal. Also, following the 10 ohm resistor, I will assume the second branch to flow through the 6 resistor in this direction, and then it comes back to the terminal afterwards. Same goes for the 1 ohm resistor. I will assume that it goes through the 10 ohm resistor, and then goes through the 1 ohm resistor, and then goes through the 4 ohm resistor, and comes back to the terminal. Now that settles it for the 10 ohm resistor. Now let's take a look at the 1 ohm resistor, because this one also have a couple of branches for us to solve. Now for the first branch, it goes through the 1 ohm resistor and then comes down to the 12 ohm resistor and then goes back to the terminal. For the second branch, as we have talked about earlier, it goes through the 1 ohm resistor and it goes through the 4 ohm resistor and then goes through the terminal. For the last branch, we will assume that it goes through the 6 ohm resistor and then it goes back to the terminal. Now, if you try to redraw the circuit following the current flow that you have assumed, you will come across something like this. Now this is a much easier circuit to follow. As you can see here, following the 1 ohm resistor, the circuit branches to 3 different branches. And we know that these 3 are parallel. So if you calculate for the total resistance going through these 3 parallel circuits, you will get that this is equivalent to 2 ohms. Now that we have this as 2 ohm resistor equivalent, we can just simply add this up with the 1 ohm resistor in series, which gives us 3 ohm in total. If you redraw this circuit once again, you will get something like this. Now at this point, calculation for the circuit would be easy, would be simple, because this is just, again, this is just a parallel circuit in 3. So calculating the equivalent resistance throughout this circuit, you will get 10 plus 1 over 3 plus 1 over 6 plus 1 over 3, all 3 reciprocated because in parallel. The final answer would be 11.2 ohms. That's it for this question. I hope you learned something from this. Thank you.